Thanya, what do you mean by ionic compounds? Ionic compounds are formed by metals and non-metals.
Yes, ma'am.
Why metals and non-metals? Can you see my screen?
Yes, ma'am.
Metals. We know that metals are electron donor. हमें क्या पता है कि metals क्या होते हैं? Electron
They
donor.
give
They give
electrons
electron. Why they give electron?
to achieve stability.
To achieve stability to complete its octet.
Yes, ma'am.
Okay. And non-metals take
They take
electrons.
electrons.
Why they take electrons?
They take electrons to form octet.
Huh. Like NaCl. NaCl. Na, it is 281.
Yes, ma'am.
Cl is 227. Sorry, 287. So what sodium will do? Sodium will give
Sodium will give electron to
one
chloride.
electron to chlorine. Na plus Cl minus.
Yes, ma'am.
And we know positive negative charge attract each other. Positive negative. So NaCl will make ionic compound. Okay.
Yes, ma'am.
Next for MgO. Magnesium. Can you tell me atomic number of magnesium?
12
And
to 8 2.
2A2.
It will give 2 electrons.
2A2. And chlorine 287. Magnesium gives 2 electron, but chlorine needs only 1 electron. So what happens here? Magnesium will give 1 electron to this one and 1 to this one, and we will get another ionic compound, that is MgCl2. Here it is 2. Here it is 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay.
Yes, ma'am.
So it will become MgCl2. Sodium oxide, NaO. Na is 281
Yes, ma'am.
and oxygen is
2,6.
oxygen needs how many electrons?
2 more electrons.
2 more electron, but sodium, this sodium element can give only 1.
Yes, ma'am.
So what will happen?
And one more in it.
NaO. So here 6 electron, 1, 2, 3, 4, 5, 6. Na outermost shell 1 electron, it will give 1. So it will become Na2O. Okay.
Yes, ma'am.
So in this way ionic compounds are formed. If as Na becomes positively charged, so it is known as cation, and chlorine becomes negatively charged, it is known as anion.
Anion.
Okay.
Yes, ma'am.
Charged ions becomes MgCl2. And what are the properties of ionic compound? They have high melting, high boiling point. Why they have high melting, high boiling point? Because they are formed by the ions. Are you getting?
Yes, ma'am.
High melting, high boiling point, strong force of attraction, solid in nature, hard. Okay,
Yes, ma'am.
these are soluble in water and insoluble in solvents such as kerosene, petrol, etc. They conduct electricity. Why they conduct electricity? Because solution of ionic compound in water contains ions, due to which electricity conducts. Okay,
Yes, ma'am.
should we read this? Want to read this one, Thanya? Please confirm.
Yes, ma'am.
Okay, start reading then, so that all the things will be clear. This one from here.
How do metals and nonmetals react? In the above activities, you saw the reactions of metals with a number of reagents. Why do metals react in this manner? Let us recall what we learnt about the electronic configuration of elements in class 9. We learned that noble gases which have a completely filled valence shell show little chemical activity. We therefore explain the reactivity of elements as a tendency to attain a completely filled valence shell.
Hmm,
Let us have the look at the electronic configuration of noble gases and some metals and nonmetals. We can see from table 3.3 that a sodium atom has one electron in its outermost shell.
hmm,
If it loses the electron from its M shell, then its L shell now becomes the outermost shell that has a stable octet. The nucleus of this atom still has 11 protons, but the number of electrons has become 10. So there is a net positive charge giving us a sodium cation Na+. On the other hand, chlorine has 7 electrons in its outermost shell. I'll see from that.
hmm,
And it requires one more electron to complete its octet. If sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine. After gaining an electron, the chlorine atom gets a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its K, L, and M shells. This gives us a chloride anion Cl minus. So both these elements can have a give and take relationship between them. Sodium and chloride ions, being oppositely charged, attract each other and are held by strong electrostatic forces of attraction to exist as sodium chloride.
hmm,
It should be noted that sodium chloride does not exist as molecules but aggregates of oppositely charged ions.
hmm. Clear? Should I explain again?
Ma'am, can you explain the last sentence?
Yes,
It
it should
should
be
be noted.
noted that the sodium chloride does not exist as molecule but aggregates of oppositely charged ion, means it formed by the combination of plus and minus charge. They combine and NaCl is formed. It is not completely one molecule. Are you getting?
Yes, ma'am.
Hmm. Let us see the formation of ionic compound. Magnesium chloride.
The compounds formed in this manner by the transfer of electrons from a metal to a nonmetal are known as ionic compounds or electrovalent compounds. Properties of ionic compounds.
Hmm. Tanya, should I explain again? Are you getting?
Mama, I understood.
Hmm.
Activity. Take samples of sodium chloride, potassium iodide, barium chloride, or any other salt from the science laboratory. What is the physical state of these salts? Take a small amount of a sample on a metal spatula and heat directly on the flame. Repeat with other samples. What did you observe? Did the samples impart any color to the flame? Do these compounds melt? Try to dissolve the samples in water, petrol, and kerosene. Are they soluble?
Hmm.
Make a circuit as shown in the figure and insert the electrodes into the solution of one salt. What did you observe? Test the other salt samples too in this manner. What is your inference about the nature of these compounds?
देखो, what happens here? This is bulb, switch, beaker, graphite rod, which act as electrode, salt solution. hmm, Under test. What happens here? Bulb glows. We have studied in physics, bulb only glow when the circuit is completed. So it means here circuit is completed. How circuit is completed? Because here it is salt solution and ions are present.
Yes, ma'am.
That's why circuit is completed.
Yes, ma'am.
Are you okay with it?
Yes, ma'am.
Okay.
You may have observed the following general properties for ionic compounds.
Hmm.
Physical nature. Ionic compounds are solids and are somewhat hard because of the strong forces of attraction between the positive and negative ions. These compounds are generally brittle and break into pieces when pressure is applied. Melting and boiling points.
Are you
Ionic
okay with physical
compounds.
nature?
Yes,
Solids
ma'am.
somewhat hard because of strong force of attraction between the positive and negative ions.
Yes, ma'am.
Hmm.
Melting and boiling points. Ionic compounds have high melting and boiling points. This is because a considerable amount of energy is required to break the strong interionic forces of attraction.
That's why actually high amount of energy is required to break the strong interionic attraction. They have high melting and boiling point.
Solubility. Electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc.
Hmm.
Ma'am, what is the reason for this?
Because kerosene and petrol, एक second, water has ions like H plus and OH minus ion. NaCl is dissolved in water,
Yes, ma'am.
so it attracts opposite ions. That's why it ionizes. But here no ions are present. Like in kerosene and petrol, no ions are present.
Yes, ma'am.
They
In my
cannot.
workbook,
Hmm.
it was written that most salts ionize in water to form acids and bases.
Yes, because
Hydrolysis of salts.
hydrolysis of salt, because charges attracts each other, opposite charges. Okay,
Yes, ma'am.
and that's why they conduct electricity. Hmm.
Conduction of electricity. The conduction of electricity through a solution involves the movement of charged particles. A solution of an ionic compound in water contains ions, which move to the opposite electrodes when electricity is passed through the solution.
Hmm.
Ionic compounds in the solid state do not conduct electricity because movement of ions in the solid is not possible due to their rigid structure. But ionic compounds conduct electricity in the molten state. This is possible in the molten state since the electrostatic forces of attraction between the oppositely charged ions are overcome due to the heat.
Hmm.
Thus, the ions move freely and conduct electricity.
Are you okay with it? Conduction of electricity through a solution involves the movement of charged particle. Charged particle means plus minus wale. A solution of ionic compound in water contains ions. And ions moves through the oppositely charged electrons, like cation will go towards the cathode,
And an ion will move towards the positively charged anode.
anion to anode. The most important thing, Tanya, ionic compounds cannot conduct electricity in solid state because ions are not present there. They are bound due to rigid structure. Ionic compounds conduct electricity in the molten state only. This is possible in the molten state since the electrostatic forces of attraction between the oppositely charged ions are overcome due to heat.
Ma'am, what exactly is a molten state?
Molten state, तान्या, ये आपको हिंदी में बताऊं तो इसे बोलते हैं पिघली हुई अवस्था. जैसे सॉलिड है वो मेल्ट जो हो गया, उसको
Oh,
मॉल्टन
okay.
स्टेट बोला जाता है. साइंटिफिकली वर्ड मॉल्टन स्टेट, मेल्टेड स्टेट है मतलब ये.
So it is heated then.
हाँ,
That's why they mentioned that the
molten, हाँ, electrostatic force
forces
of
of
attraction
attraction are overcome due to the heat.
due to heat. Solid becomes liquid when it gains heat. Okay.
Yes, ma'am.
Thus the ions move freely and conduct electricity. Okay.
Yes, ma'am.
Here you have to prepare electron dot structure for sodium, oxygen and magnesium. Formation of Na2O MgO. Ions present in these compounds you have to tell. Hmm. Okay, Thanya.
Yes, ma'am.
Now occurrence of metals. Thanya, should I explain anything again?
Yes, ma'am. Can you give a recap of the occurrence of metals?
Occurrence of metals I am telling. I am asking about ionic compounds.
Yes, ma'am. I
Ionic
understood.
ionic compounds understood. Occurrence of
Yes,
metals I am
ma'am.
explaining.
Okay, ma'am.
Okay, occurrence of metals. Thanya, we get metals from the earth.
Yes, ma'am.
अर्थ क्रस्ट पहले मैं आपको एक रिकैप देती हूँ आफ्टर दैट वी विल रीड इट here are the reactivity series which shows which is formed according to the reactivity of metals. Metals on the top are highly reactive and as we go down they are least reactive. Okay, so here
Yes, ma'am.
the state of metal, yeah, the condition of metal, they we get them from the earth's crust known as ore. So firstly what we do, concentration of ore means after washing it, ore is concentrated. There are three steps. There are three steps. What are these three steps? Metals of high reactivity, metals of medium reactivity, metals of low reactivity. Metals of high reactivity means electrolysis. Sorry, metals of high reactivity which are top on the reactivity series, उसके लिए हम क्या करेंगे, electrolysis of molten ore and we will get pure metal. Metals of medium reactivity we can get in two state, yeah, two condition, carbonate ore or sulfide ore. If they are carbonate ore we do calcination and roasting, we get oxide of metal. When oxide of metal is reduced we get purification, means reduction of metal, क्या metal मिला and then it is purified to get pure metal. Metals of low reactivity, sulfide ore के case में we do roasting as we done previous in metals of medium reactivity, we get metal and after refining it we get pure metal. Now question arise, what is calcination and what is roasting? Calcination we do for carbonate ore and
Yes,
roasting
ma'am.
for
Sulfide ore.
sulfide ore. So in roasting, I am explaining it from here. In roasting, sulfide ore is heated with oxygen and sufficient amount of oxygen. We get oxide of ore. Okay,
Yes, ma'am.
and then it is reduced to get metal. In calcination carbonate ore, we get oxide which is reduced. Here it is heat in less amount of air, limited amount of air, but in roasting it is heated in high amount of air. Okay,
Yes, ma'am.
okay, bus. Okay, start to read. In case of any doubt you can ask. Yes, start to read. Occurrence of metals.
Occurrence of metals. The Earth's crust is a major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. The elements or compounds. which occur naturally in the Earth's crust, are known as minerals. Minerals contain a very high percentage of a particular metal, and the metal can be profitably extracted from it. These minerals are called ores.
Hmm. Extraction of metals. Are you okay with it? What are ores?
Yes, ma'am.
Hmm. Where they are found on earth crust? Ores are by which we can get profitably metals, मतलब प्रॉफिट उसमें हमें मिलेगा, ज्यादा मेटल उसमें हमें मिलेगा. Extraction.
Some metals are found in the Earth's crust in the free state. Some are found in the form of their compounds. The metals at the bottom of the activity series are the least reactive. They are often found in a free state.
Hmm. Metals which are least reactive, they are found in free state because they do not react with any other element. But
Yes, ma'am.
if metals are highly reactive, they combine with other elements. Least reactive like gold, silver, platinum and copper.
Copper and silver are also found in the combined state as their sulfide ores or oxide ores. The metals at the top of the activity series, potassium, sodium, calcium, magnesium, and aluminium, are so reactive that they are never found in nature as free elements.
Hmm.
The metals in the middle of the activity series, zinc, iron, lead, etc., are moderately reactive. They are found in the Earth's crust mainly as oxides, sulfides, or carbonates. You will find that the ores of many metals are oxides. This is because oxygen is a very reactive metal and is very abundant on Earth.
So many ores like as oxides. Here three condition: highly reactive, moderate reactive, less reactive, least reactive. So if they are least reactive, they are found in free state.
Yes,
Copper
ma'am.
and silver are also found in combined state as sulfide and oxide ores. Top of the series like sodium, potassium, sodium, calcium, magnesium, aluminium, very reactive. That's why we can never find them in free state, free elements. The metals in the middle of activity series like this one are moderately reactive. Moderately means बहुत ज़्यादा reactive भी नहीं, बहुत कम reactive भी नहीं. And they are found as oxide, sulfide and carbonate ore. You will
Yes, ma'am.
find that the ores of many metals are oxide. This is because oxygen is very reactive metal and is very abundant on the earth.
Earth.
Thus on the basis of reactivity.
We can group the metals into following three categories: metals of low reactivity, metals of medium reactivity, and metals of high reactivity.
Hmm.
Different techniques are to be used for obtaining the metals falling in each category.
Each category, and we have done this one, different categories.
Ma'am, the electrolysis is done when we need a substance to decompose
So pure
or
metal.
go through a decomposition reaction, right?
But
Generally, ma'am.
generally if you are asking, then electrolysis means like ionization takes place. It is breaking down, decomposition you can see.
So, electrolysis always involves a decomposition reaction.
But used for different purpose. As here electrolysis, we are getting pure metal.
Yes, ma'am. Yes,
But
ma'am, the purpose is different,
different
but it always
decomposition.
has a decomposition.
टूटना, because towards cathode cation will go and towards anode anion will go.
Yes, ma'am.
Enrichment of ores means like enrichment of ores means it is contaminated with large amount of impurities जैसे कि soil sand. It is called gang. Then it is washed, it is removed prior to extraction of the metal. Hmm.
Ores mined from the earth are usually contaminated with large amount of impurities such as soil, sand, etc. called gangue. The impurities must be removed from the ore prior to the extraction of the metal. The processes used for removing the gangue from the ore are based on the differences between the physical or chemical properties of the gangue and the
Hmm.
ore. Different separation techniques are accordingly employed.
Hmm.
Extracting metals low in the activity series.
Hmm.
Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar HGS is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide. Mercuric oxide is then reduced to mercury on further heating.
Hmm.
Similarly, copper, which is found as Cu2S in nature, can be
CU2 sulfide फॉर्म में है in nature.
Cu2S
Hmm.
in nature can be obtained from its ore by just heating in air.
Hmm.
Extracting metals in the middle of the activity series. The metals in the middle of the activity series, such as iron, zinc, lead, and copper, are moderately reactive.
Hmm.
These are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. Ma'am, why is it that it is easier to obtain metal from its oxide compared to?
Simple reduction. After that, simple reduction takes place.
Ma'am, if they ask this in the form of a question, then how would we write the answer?
You are asking why oxides. It is easier to get metals
Yes, ma'am.
from their oxides easily because by reduction of the oxides of metal we get metal, and after refining it we get pure metal.
Ma'am, why is it easier than compared to obtaining metal from sulfide and carbonate?
Because in sulfide and carbonate they cannot be easily reduced. Sulfur here, sulfide is attached, here carbonate is attached, they cannot be easily removed from the metal. Getting?
Yes,
But
ma'am.
in case of oxide, by simple reduction we can get pure metal.
Okay, ma'am.
Hmm. Continue.
The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting.
Hmm.
The carbonate ores are changed into oxide by strongly heating in limited air. This process is known as calcination. The chemical reaction that takes place during roasting and calcination of zinc ores can be shown as follows. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it is then reduced to metallic zinc.
Hmm.
Obtaining metals from their compounds is also a reduction process. Besides using carbon, coke, to reduce metal oxides to metals, sometimes displacement reactions can also be used.
Hmm.
The highly reactive metals such as sodium, calcium, aluminium, etc., are used as reducing
Reducing
agents because they can displace metals of lower reactivity from their compounds.
compounds. Here, displacement reaction. It can easily, oxygen can be easily displaced by aluminium.
Yes, ma'am.
Hmm.
These displacement reactions are highly exothermic. The amount of heat evolved is so large that the metals are produced in the molten state. In fact, the reaction of iron 3 oxide Fe2O3 with aluminium is used to join railway tracks or cracked machine parts. This reaction is known as the Thermit reaction.
Thermit reaction. Welding. Have you ever heard about the welding?
Yes, ma'am.
This is the reaction Fe2O3 plus 2Al FeAl2O3 plus heat. Okay?
Yes, ma'am.
Hmm.
Extracting metals towards the top of the reactivity series. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminium, etc. to the respective metals. This is because these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction.
Hmm.
For example, sodium, magnesium, and calcium are obtained by the electrolysis of their molten chlorides.
Here, Thanya, the metals high up in reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. because they are highly reactive. And carbon cannot reduce the oxides of sodium, magnesium, calcium, and aluminium to their respective metals because these metals are highly reactive and have more affinity towards the oxygen than carbon. That's why carbon cannot detach them from the oxygen. Are you getting the point?
Yes, ma'am.
For this purpose, electrolytic reduction is used. In electrolytic reduction, like electrolysis, at cathode sodium we will get sodium, and at anode we will get chlorine.
Ma'am, this diagram is not given in the textbook. Can you just once draw a simple diagram of electrolytic reduction?
This one type
Ma'am, that is refining, ma'am.
refining, but the diagram is the same. Like we will have the salt solution, here electrodes, okay, battery, NaCl solution, you will write NaCl solution. It is positively charged, negatively charged, towards positively charged, and chlorine, and here sodium. Okay.
Yes, ma'am. Sodium, magnesium, and calcium are obtained by the electrolysis of their molten chlorides.
Hmm,
The metals are deposited at the cathode, the negatively charged electrode, where chlorine is liberated at the anode.
huh.
The reactions are
Tanya,
similarly.
are you okay with this diagram?
Yes, ma'am.
Nothing else is given here. I checked it. Here only where we are getting chlorine. Here like dot dot type to show that chlorine gas is formed. We are getting chlorine in the form of gas. Here dot dot type. Okay?
Yes, ma'am.
Hmm.
Similarly, aluminium is obtained by the electrolytic reduction of aluminium oxide.
Okay? Aluminium,
Yes, ma'am.
reduction of aluminium oxide. In case of aluminium oxide, we will get aluminium towards cathode or anode. Aluminium,
Towards the cathode
and oxygen gas towards.
anode.
Now refining of metals.
The metals produced by various reduction processes described above are not very pure. They contain impurities which must be removed to obtain pure metals.
Hmm.
The most widely used method for refining impure metals is electrolytic refining.
Refining, electrolytic refining means electrolysis process takes place here. Hmm.
Electrolytic refining. Many metals such as copper, zinc, tin, nickel, silver, gold, etc. are refined electrolytically.
Hmm.
In this process, the impure metal is made the anode and a thin strip of pure metal is made the cathode.
Hmm.
A solution of the metal salt is used as an electrolyte. The apparatus is set up as shown in the figure. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte.
Are you getting it? This is electrolytic refining. Copper, zinc, tin, nickel, silver, gold. These are refined electrolytically. What happens in this process, Thania? The most important thing, impure metal is made the anode, and pure metal is made the cathode.
Ma'am,
Why?
so from the anode, the pure metal
Huh.
dissolves into the electrolyte, then
Sorry.
it deposits on the cathode.
It deposits on the cathode. So after some time, what will happen? What will happen? Cathode will become thicker than that of anode, and here we are getting impurities. Anode mud. It is also known as anode mud.
Yes, ma'am.
Hmm.
Ma'am, that's it, ma'am. I
That's it.
didn't have any other doubts from.
Okay. Any other doubt?
No, ma'am. Everything else is clear.